Today we're going to be talking about vectors, specifically dot products of vectors. So in the last section we talked about how to find the magnitude of the resultant vector between two vectors. The one thing that we didn't mention was the angle between those. And we always found it so that there would be a 90-degree angle. But that's not always the case. And that's where a dot product comes into play. A dot product is when you multiply two vectors together, it's read as A dot B, and you get this value right here. Now you'll notice that when we talked about scalar multiplication with a vector, we ended up getting a vector as an answer. But in a dot product, you end up getting a number as your answer. Okay? And that number, what we want is for it to be 0. If our number is 0 with our dot product, two lines are called orthogonal. And essentially what an orthogonal vectors are is vectors that meet at a 90-degree angle, or are known as perpendicular. So if we look at this example right here, it says find the dot product of UV, then determine if UV are orthogonal vectors. So if I'm going to look at UV right here, U dot V is going to be equal to A1 times A2, so 3 times negative 4, plus 6 times 2. So I multiply those together, and I get negative 12 plus a positive 12, which equals 0. So since it added up to 0, that means that these lines are orthogonal. So are they orthogonal? Yes. And you can see the picture right here. Okay? Right here they meet at a 90-degree angle, which is what we're looking for. Let's look at example B. U dot V is equal to 2 times 8 plus 5 times 4. Well, 2 times 8 is 16 plus 5 times 4 is 20, adds up to 36. So are these orthogonal vectors? The answer is no. And again, if we graphed them, you can see this right here and this right here. And it does not form a 90-degree angle. So these are not perpendicular vectors. They're not orthogonal. Okay, some properties of dot products. Okay, commutative property says that it doesn't matter the order in which you do your dot product, it'll always remain the same. The distributive property of a dot product, if you're going to take the dot product between U plus V plus W, it's the same as the dot product of UV plus the dot product of UW. Then we have scalar multiplication. So if I took some number and multiplied it by the dot product, it's the same as taking that number times U dot product of V, or U times the dot product of K times V. Okay? Notice K only shows up multiplied by one of the vectors, not both of them. A little bit different. The zero product, dot product, says that 0 times anything is equal to 0, which is good. It means that the 0 vector adds up to 0. But a 0 vector is not orthogonal to any vector because it has no magnitude. Finally, the last one, dot product and vector magnitude relationship, says that if you find the dot product between the same vector, it's going to be equal to the magnitude squared. And there's a proof of it right there. Kind of helps you out, but not necessary to keep memorized. All right, so it says use the dot product to find the magnitude of A. A's components are negative 5 and 2. So we're going to use that last example that we just talked about. Okay, so it says this, that the magnitude of A squared is equal to the dot product of A and A. So that's what I'm going to do. I'm just going to say, okay, well, A is negative 5, 12. Okay, and dot product is negative 5, 12. Okay, so A1 times A2 plus B1 times B2. So I get 25 plus 144 equal to 169. Now you'll notice then that to figure out what it is, I have to take the square root of this number, which is equal to 13. So what's the magnitude of this vector right here? It's 13. Again, that's the same as what we talked about before, last section, which was the square root of a squared plus b squared, just a little bit different looking at it using dot products. All right, so we can also find the angle between two vectors that are not specifically on the coordinate plane or are 90 degrees. And this is the equation right here. Cosine of our theta angle is equal to the dot product of a times b multiplied by their magnitudes. Okay? Here's the proof. Again, not very important for you to have that memorized, but it is there if you'd like to see it. So we need to find the angle theta between vectors u and v to the nearest tenth of a degree. So we go to our equation that we just looked at. Cosine of theta is equal to the dot product of u and v times the magnitudes of u and v. Well, dot product would say that that's going to be a1 times a2, so 6 times negative 4, plus b1 plus b2, all over their magnitudes. Well, if I'm looking at the magnitude of u, that's going to be the square root of 6 squared plus 2 squared, which is equal to the square root of 36 plus 4, that's the square root of 40. Okay, so right here I have square root of 40 times, and then the magnitude of v is going to be the square root of negative 4 squared plus 3 squared. Okay, square root of that, 16 plus 9 is square root of 25 times the square root of 25. Okay, so continue on. 6 times negative 4 is negative 24 plus 2 times 3 is 6, all over square root of 40. Don't know what that is. Square root of 25, that's 5. So this is 5 square roots of 40. We end up getting negative 18 over 5 square roots of 40. Now we could simplify this a little bit farther. The nice thing is our calculator is actually going to do this. So that means that cosine of theta is equal to this. So if I want to figure out my angle, if cosine theta is equal to negative 18 over 5 square roots of 40, I have to take the inverse cosine of both sides. And I find that theta then to the nearest tenth of a degree ends up being approximately 124.7 degrees. Now let's look at example B. Example B has vectors 3, 1 and 3, negative 3. So if we're going to find the angle between them, again it's the dot product of u and v over the magnitudes of u times magnitude of v. So first, I'd say, okay, well the dot product is going to be 3 times 3 plus 1 times negative 3 over, and now I have to know the magnitude. Magnitude of u is going to be the square root of 3 squared plus 1 squared, which would be 3 plus 1 is, or excuse me, 3 squared is 9 plus 1 is 10. Magnitudes of v is going to be the square root of 3 squared plus negative 3 squared. So that's the square root of 3 squared is 9, negative 3 squared is 9, 18. So we get the square root of 10 times the square root of 18. 3 times 3 is 9 plus 1 times negative 3 is negative 3 over square root of 10 times square root of 18 is the square root of 180. If I wanted to simplify this any farther, I'd say, okay, well, what are the factors of 180? Well, the factors of 180 that I could take out as a perfect square, I could do 36 and 5. So the square root of 36 is 6 square root of 5 over, and then 9 plus negative 3 is 6. So that's kind of nice that we have those 6's cancel each other out. So that's 1 over the square root of 5. I could do then square root of 5 over 5, but the nice thing is my calculator takes care of it from there. So cosine of theta is actually the same as 1 over the square root of 5. Now to figure out what theta is, I'm going to have to take the inverse cosine of both sides. And I find that theta then to the nearest tenth of a degree ends up being 63.4 degrees. There's a couple examples that you can try to find the angle between them as well.